Wait a minute here for some other people to log on, but just wanted to introduce myself. I'm Andrew Peterson, Director of Education. And today we're going to be talking about circles and the process of completing the square. So just stand by for another 30 seconds or so just to let some people sign in and get on our live video, and we will get things going. All right, well, let's get to it. Again, we're talking about circles today and the process of completing the square. As we get into our first slide right here, just a quick reminder to everyone, we at Method Test Prep offer online tutoring, always and especially during the current circumstances. Not just for SAT and ACT prep, despite the fact that those June tests are still scheduled and right around the corner, but for all subjects. We do get students who are looking to meet on a weekly basis for tutoring just to help out with that class that's a little bit challenging. Students not really getting the same amount of face time that they typically get for those subjects. But we also help prepare students for those one-off tests that they have. A few students of mine have asked for some help in calculus, algebra 2, both chem and biology. I've gotten requests for all of those subjects. So just as a reminder, if you are interested in regular tutoring or just a one-off session to brush up on some of those confusing aspects if you can't get your teacher on a Zoom session, make sure to either give us a ring or reach us online, methodtestprep.com/online-tutoring. All right, and let's get down to the nuts and bolts of today. So as promised, we're talking about circles, and circle equations is where it all starts. This is an example of a standard circle equation. And let's talk about actually what we're seeing here in this equation. The equation is x minus h quantity squared plus y minus k quantity squared equals r squared. That's a lot of letters and variables. So let's see what all this stuff actually means. In this first parenthetical, when we get this x minus h and this y minus k, both quantity squared, those h and k's actually translate into the x and y coordinates of the center of the circle. Now, notice here that they're expressed as negatives in the equation, and we have to express them as positives for the center of the circle. What this really means mathematically is we always take the opposite of the value that's given to us. So for example, if we were given x minus 2 quantity squared plus y plus 5 quantity squared, let's say that was equal to 25. This would mean that the center would be at changing the sign positive 2 and again changing the sign negative 5. This is similar to the process of factoring when you take a quadratic or a trinomial and you quote unquote double bubble it. You change those values once you find the double bubbles to solve for x. You find the opposite value of what's given in the parentheses. And circles really are no different when you're trying to find the center. So again, expressed as negatives in the equation, they come out as positives for the real center. If they're expressed as positives, as we evidenced over here with the positive 5, they become a negative for the center. The last element we want to talk about here is the one on the other side of the equal sign, this r squared. When we're dealing with circles, the square of the radius is this constant that we get on the other side. Now, it's important to remember that this is not the radius itself, but the square of the radius. And it's not all the time that you're going to get a nice perfect square, but it does make us feel nice and comfortable to get a number like 25 over on the right-hand side. Why? Well, that would mean in this case that the square of the radius is equal to 25, and well, if we square root both sides, this would mean that the radius is in fact equal to 5. It's a nice whole round number. Again, the SAT and the ACT will not always give you nice perfect squares over on the right-hand side, but when they do, it does make the problem a little bit easier. So moving forward, we'll get another example here after the one we talked about, and let's see if we can work through this one as well. So if we were trying to find the center, in this case, of this circle, All right, we're going to take a look at the numbers that are inside of these bubbles over here, these squared parentheticals, and we're going to change the sign. So I see a -4 here for the x term. I'm going to write a +4 down in my parenthetical here. And for the second term, I see a +1. Well, I'm going to flip that sign to a -1. Great. So I've got a center of 4, -1 for this circle. And I see this 16. Again, we get nice and happy that it's a perfect square. And this means that the radius is equal to the square root of that number at a value of 4. All right. So it seems like we've got our circle equations down. Let's move on and let's see what we've got next. So, right, with that knowledge, we're all set, right? What else? I mean, what else could the SAT or ACT throw at us if we're able to come up with the center and the radius of the circle? Well, yeah, not so fast. I'm sure by now we all know the SAT and ACT well enough to know that they're not just going to help us spell it out and make life really easy. We're going to need to get a little bit creative. So here's the reason that we need to get creative, and this is a problem that we're going to talk about in depth in just a minute. I will be solving this problem out. But taking a look at question 24 down on the bottom, you probably noticed a couple of things. You probably noticed that they're asking us for the radius of the circle, and this isn't crazy. We were just talking about how to find the radius of the circle. But one thing that some of you may be thinking right now is, hey, Andrew, it has a -1 over here, right? And isn't this supposed to be the square of the radius? So, Andrew, are you telling me that the square of the radius is equal to -1? Because if it is, we've got a problem. I'm going to need to take the square root of a negative number, and our calculators give us an error when we do that. If you've been into imaginary numbers before, you know that that's not necessarily a big comfort zone for us, and this would be creating a big problem for solution. I guess at the same time, fortunately and unfortunately, that's not exactly what we have to do. And the reason we can't just square root that side like we could earlier is because the equation is not in the appropriate form right now. Right? Notice that we don't have these two squared parentheticals, x plus or minus something squared plus y plus or minus something squared. We don't have that. We kind of just have this standard form of an equation. And so this means that it's our job to turn this confusing looking equation into something that's not so confusing. And this is where this process of completing the square comes in. So the issue at hand, again, to restate it, is that that equation we were just given, it doesn't look like this equation right here. And I did skip ahead a couple steps when I made this slide. This is the equation right here that we will be getting momentarily once we change things around and we work through the problem. But it doesn't look like that. So our job here is going to be to make it look like that. So let's see how we get from the equation that we're given, which is this one again, posted right there, which is wrong, and let's see how we get it to the one that we need in order to solve the problem. And that's this one right here that we're going to be looking into. All right, let's dive in. So here's this example. Same thing we saw before. We're looking for the radius of the circle, which is great news to us because once we put it in the appropriate form, all we need to do is square root the right side of the equation. So let's start. What we're going to want to do is we're going to want to group our x terms together. So I'm taking my x squared, I'm taking my positive 4x right here. I'm going to group them together. And I'm actually going to leave a little room here over to the right. We'll see why in just a second. I'm going to take my y terms, and that's a positive y squared that I have here, as well as my -2y. I'm going to group them together, again leaving a little room over here to the right. All right, make it equal to -1. So there's a trick here that we can use, but let me talk through why the trick makes sense before I actually use it. And this will help us speed up these problems. We can help ourselves with this trick in the next couple of examples that I give after this one. What we need to do, again, is we need to turn this element right here into a squared parenthetical, x plus or minus something squared. Now remember, when we have this square up here, this means that we're taking whatever this term is, and we are multiplying it by itself. It's the same as anything squared. 5 squared is 25. Why? Well, because 5 times 5 squared, is 25. So it just means we're multiplying it by itself. Well, that means that, for example, and I'll talk through how I got here, if I had x plus 2 quantity squared And I actually did the foiling work on this one. X plus 2 times x plus 2, right? This is truly squaring something, multiplying it by itself. If I foiled, I know some of us may do box method as well. I'm an old dinosaur that was taught how to do FOIL. Then we're multiplying these numbers in succession just like this. So we would come out with x squared, we would get another plus 2x, we'd get another plus 2x, and then we would get plus 4. All right, and that works out nicely for us. We can get, again, combining like terms, x squared plus 4x plus 4. Now look at this term that I just got. These first two terms here, x squared plus 4x, this looks exactly like what I had right down here, which is great news for me because it means I'm really, really close to getting this x plus 2 quantity squared, but I'm just missing something. I'm missing this plus 4 over here. And this may seem weird if we've never done this before, but it works out beautifully mathematically. If I'm missing something like a positive 4, well, I can actually just go ahead and add it right into the equation. Now, I can't just do this freely without doing something else, but remember, anytime you solve an equation, let's say we have x plus 4 equals 7. Now, if I was solving for x here, I would just subtract 4 from both sides. We've all done this thousands of times. We'd find that x is equal to 3. And this isn't anything crazy. This is just a normal algebraic solution. But notice what I did. I subtracted 4 from both sides, right? Seems normal here. May seem a little weird to add a 4 up on this side. But if I subtract a 4 from this side, that's fine as long as I subtract a 4 from the other side. So to our point here, if I'm just going to add this 4 in, seemingly randomly, to get that value over there, well, if I'm adding a 4 to the left-hand side, what do I need to do? Well, I just need to add that same 4 over to the right-hand side. All right, so I'm going to go over here, and I'm going to add this 4. Okay. Now the same thing for this term. We can hopefully figure out what we can put into place. And I'm going to take that step ahead and show you what this should be, and then we'll talk about how I got both of these parentheticals. It should look like this. Notice what happens when we FOIL. We get y squared minus y plus 1. Make that a little bit more of a clear minus right there. Plus 1. Okay, when we combine our like terms, hey, y squared minus 2y, this is looking great. Plus 1, okay. So first two terms right here, great, reflected up above, just like we saw before. But I have this 1 that I need. In order to make this a parenthetical, I have to put this plus 1 over here. Okay, well, if I add 1 to this side, I need to add 1 to this side as well. All right. Now notice what this becomes. This becomes these two terms right here. This one becomes x plus 2 quantity squared. The other one becomes, right, this guy right here. This becomes y minus 1 quantity squared. And over on the right-hand side, this negative 1 and positive 1, they just cancel out to make 0. Leaves us with a value of 4 over here. That's a perfect square. It makes us happy. And there we have a much more manageable equation. Now, before we answer this question, let's talk about how I went through and I got this x plus 2 quantity squared and y minus 1 quantity squared. I kind of just came up with it out of nowhere. Well, the trick here is when we have a term that's being multiplied by itself, when we are FOILing, notice what happens. This 2 that we have over here in the parenthetical, we actually double that value to make this x term down here 4x, right? We're adding 2x twice. Here's it once and another time. We double this 2 to make this 4x that we have up here, this 4x that we have down here. Now, to get this 4 over on this side, we actually have to square the 2, right? Notice that 2 times 2 is equal to 4. And that's how we get this 4 over here. So again, this term doubles to become the coefficient of the middle term, and this term squares to become this constant term over here. We can see the same thing happening over on this right-hand side. right? This -1, it doubles, multiply by 2, it doubles to become -2. But when we square it, -1 times -1, we get +1. And this is where the trick lies. Here's the trick, and we'll use it in more detail on the next one. You find the coefficient of your x value, in this case 4, and in this case -2. We divide that value by 2. That gives us this number right here. And then when we square it, we get this constant that we're trying to add. So again, you divide the coefficient of your x term by 2, in this case giving us 2, and then when we square it, we get 4. Over here, we divide this term by 2 to get -1, and we square it to get +1. These are the numbers that we are adding to the left and right-hand side of the equation. Now, to answer question 24 right now, we can take a look, and it's asking for the radius. Well, we already did the hard work, and a lot of it. We got to this point, which means that the radius, or at least the square of the radius, is equal to this number right over here, 4. So if the square of the radius is equal to 4, and we square root both sides, we'll be able to find that the radius is equal to 2, and therefore answer choice A is correct for this problem. All right, let's try another one now that we have a little bit more seasoning on ourselves. So the equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? Okay, so a bit of a different question here. Coordinates of the center, right? It's not looking for the radius, but that's okay. We talked about how to get the coordinates of the center. And these numbers are a little bit larger, but fortunately, they actually grouped them together for us. Remember in the last one, they kind of separated them? Well, here they put the x's and the y's together, which is really nice and helpful. So let's use our little trick, right? We're going to space this stuff out to kind of see what we're adding to both sides. I'm going to leave a little space right there. So we get this plus y squared plus 16y. Again, leaving another space. And then we have our -20 over on the other side. All right, so here's our trick. Let's take the coefficient of the x term and let's divide by 2. Remember, that gives us this number right here, 10. Okay, now we will take this and we will square it to get plus 100. If I did the same thing over for the y term, I would take this 16, I would divide it by 2. Great, that's going to give me this number right here, y plus 8, quantity squared. All right, we get that 8, we square it, and we get 64. Now remember, if I'm adding these to the left-hand side, I have to add them to the right-hand side. Now I would typically go through and do this because it's good practice, and we can actually see that we would add a 100 and a 64. When we subtract 20 from 164, we get 144, which makes us very happy. Again, perfect square. It means the radius is equal to 12, but I'm not going to do that here. And why am I not going to do that? Well, look at what the question is asking for. It's asking for the coordinates of the center of the circle. It's not asking for the radius. So doing that would actually be extra work. It would be correct work. And again, good practice, which is why I'm mentioning it on this presentation. But ultimately, it's not information we need. Why not? Well, remember, if we're looking for the center of the circle, we get it from both of these parentheticals here, right? These are added together. Well, all we need to do, remember, is just take that value, positive 10, and change the sign, right? So it's going to be a -10. What do we do with that positive 8? Oh yeah, we take it and we just change the sign, and it's going to be a -8. And now all of a sudden the problem is solved for us, and we saved ourselves a little bit of time from doing some work that we didn't have to do. Again, always great practice, and I want us to be very fluid in our solutions, but ultimately we always want to focus very specifically on what the actual test is asking us to do, so be aware of your questions. All right, we've got one more example before we call it a day, and this one looks a little bit different. Of course it does. They're going to throw you some curveballs on the test. What else is new? Now, the biggest issue here is we are not starting with a regular x term or a regular y squared term. This is going to get in our way of producing this x minus h quantity squared, because x times x is going to be x squared, not 2x squared. Same thing over here for our 2y squared. And because this is causing us such an issue, what we're going to do is we're going to see if we can actually just get rid of this 2 immediately. And the way we're going to do that is we're going to divide both sides of the equation by 2. This works a little bit better on the left side than on the right side, but these questions are almost always given on the calculator portion of the SAT, and therefore you can do this relatively easily using your Texas Instruments calculator. So if we split this up and divide by 2, we're going to get x squared minus 3x, leaving some space, plus y squared plus y equals 45 over 2. I'm going to express this as a decimal of 22.5. It'll just be a little bit easier toward the end of the problem. You can certainly leave it as a fraction, but remember, you do have your calculator here, so you can just use it to turn it directly into a decimal. All right, failed to leave a little space over here, but we'll just get a little bit creative with that. Alrighty, so what do we do? Well, we're going to divide this number by 2, and then we're going to square it. All right, so we're going to get x minus 1.5. Again, thankfully, this is a calculator question because we can just take negative 1.5 and square it. Calculator will tell you that's equal to 2.25, positive 2.25. Okay, we're adding that in. All right, well, if I add it on the left-hand side, I have to add it on the right-hand side. So 2.25, great. And then we're going to do the same thing over here. This is a coefficient of 1. We're going to divide it by 2. That means we're going to get y plus 0.5 or y plus 1/2 squared. And then we have to square 0.5, square 1/2, and that is going to add a positive 0.25. Again, calculator work, everybody. That means if we're adding a 0.25 on the left, we're going to add a 0.25 on the right. And this means that the total amount that we're adding to this side is 2.5. We already have a 22.5, and when we add those together, we get a value of 25. Now, despite the fact that the center of the circle certainly is 1.5 comma negative 0.5 or negative 1/2, we don't care. Why? Well, it's looking for the radius of the circle. Remember, the square of the radius is equal to what's on the right-hand side. We have this nice, very well-ordered and happy 25. We love those perfect squares. We can now square root both sides and find that answer choice A is correct for number 27. All right, so great job, everyone. Just a couple of reminders. Test Prep Time Plus. We run it every Monday through Friday at 1 p.m. Eastern. It's only $10, and it's a hyper-focused 20 to 30 minutes of SAT, ACT strategy. The hyper focus is probably the best part about it. It's not going around and only digging a little bit into a couple of subjects. When you hop on and you do so for 20 to 30 minutes, you become a master of that material that we're teaching. It's a great way to stay busy and a great way to continue prep as we're moving toward the upcoming exams. You can enroll online at methodtestprep.com/test-prep-time-plus or by calling us at 877-871-PREP. Online self-paced program, as always, wonderful tool for you self-starters out there or those who just want to supplement any other prep that you're doing, whether you're working through classes online or anything else, private tutoring. It's a great way to supplement. We are giving you 50% off with the code FUTURE. So go ahead and join our website and you can type in that code FUTURE, get 50% off. For $99.50, you get access to our online self-paced program. Great tool. SAT and ACT classes for all situations as well. Methodtestprep.com/classes. We have options on multiple times and days, so take a look at those. And as always, please visit and subscribe to our blog, info.methodtestprep.com/blog. If you have any questions about anything, please give us a ring, 877-871-PREP. And thanks again for joining us today. We will be on at 1 o'clock for our Test Prep Time Plus, and again at 11 a.m. tomorrow. We hope you got a lot out of the session today and look forward to seeing you on soon. Thanks again, everybody.